What's up, Algebra 2.1? We are going to be reviewing Unit 1 today. Before we do that, we're going to go through some bell work, going over nonlinear systems so that you're prepared for the homework quiz. And then I'm going to go through slide by slide a lot of examples that we have seen before on homework quizzes, but that you'll also see on the Unit 1 review and that you'll also see on the Unit 1 test. I'm going to go through a lot of those examples today. So stay tuned. Let's go through a lot of these. Now, most of these are going to be ones, you're not going to have all of these on the homework quiz. You'll only have 3. So most of these I'll probably actually put on Desmos, to be honest. So like this one, I'm actually going to solve by hand. I'm going to show you how to solve by hand, but sometimes I will just default to Desmos, okay? So right here, let's go through this one. Substitution, I would personally want to do substitution on this one just because it's y equals, so I'm going to substitute it right here. So this is 5x plus 2, and then this will be times x plus 4 squared equals negative 8. And so this is 5x plus 2, and then this is x squared plus 8x plus 16, and then equals negative 8. Now, how did I do that? I just FOILed it out. I'm actually not going to show you this. I feel like we should be solid with foiling out. Squared is just that, and I FOIL everything out, and I get this when I simplify. Okay? I get that when I simplify. Sweet. So when I start multiplying this stuff out, I get 2x squared plus 16x and then plus 32 equals negative 8. Okay? And then this is going to be these two together. So this is 2x squared, and this is going to be plus 21x, and then I add the 4 over. If I add the 8 over, what I have is plus 40 equals 0. Okay, so this is a quadratic. This is what I have. Let's try to plug. We can try to factor this, but I'm not going to show you that factoring method right now. So I'm actually just going to go straight to Desmos from here. So if you ever get stuck, let's just say you ever get stuck in the math. I know how to do the math. I know how to factor it, but like I said, I'm not going to show you because I'd rather show you that kind of math later on in the quarter. So I'd rather just go to Desmos straight up right here. So even if we plug this in, we get some value of x, or we plug plug the whole thing in and go straight to Desmos, we get our x and y. It does not matter. So let's go to Desmos. Okay, so if I plug this into Desmos, I get this. So this is what I have. It is factorable. It does cross the x-axis at 2 points, negative 2.5 and negative 8. So I'm going to take that negative 2.5 and translate it into a fraction. So that's negative 5 halves, and then I have negative 8. So I have x equals negative 5 halves and negative 8. So that's what I'm going to say. So x equals negative 5 halves, and then x will also equal negative 8. So it's just that simple, guys. Now, this is not my answer. I also need to find my y, which means I will plug it into my first equation. Okay, so this is y equals, and then I have negative 5 halves, then plus 4, and then squared. How do I do that? I have to combine like terms, of course. So times 2 gives me 2, times 2 gives me 8. So this is just actually 3 halves. And then I square that, which gives me 9 all over 4. So what's my actual point? My point is negative 5 halves, comma 9 all over 4. So that is my actual point here. That's one of my points. My other point is when I plug it in, my other x, I get negative 8, and then falling right here, plus 4, and then squared. So this becomes negative 4 squared, which is just 16. So my other point is negative 8 and then comma 16. So this is my other point. Okay? So those 2 points. Now I kind of did a variety of Desmos work and some algebra, and you could do that. Like in these questions, you can definitely do like half Desmos, half algebra if you wanted to. Like that's totally understandable. I would definitely do the same thing. So if you ever need to use Desmos as you're going through this, then just do that. Let's erase. Okay, this one, I'm going to solve this one by hand, and we're going to go through the substitution method. Okay. Actually, you know what? Let's not, yeah, let's do the substitution method. I was thinking like elimination, but, we definitely could go through elimination, but I'm not going to. Let's just do the substitution. This is negative x squared plus 6x plus 9. I'm just going to take this and plug it in right there. Equals x squared plus 2x plus 3. Let's get everything on the left side here. Sorry, the right side. So this will be 0. I add that over, so this is plus 2x. Subtract the 6x over, so negative 4x. That was kind of gross looking. So negative 4x. Subtract the 9 over, so this is negative 6. Divide everything by 2, so x squared minus 2x minus 3. And this actually will become x minus 3, and then x minus plus 1. So x equals 3 and negative 1. Sweet. And then I can find my y's as such by plugging them in. Okay, so if I take that one right here, if I want to find my y's, I plug in 3, so 3 squared, just falling right here, is 9. And then plus 6, because 2 times 3 is 6, and then plus 3. So this is 15, so 18, and so that means this is 3 comma 18. I know I'm going a little bit fast here, but I think that's okay. I'm sorry if I am going fast. I apologize. Just go back through the video, kind of follow along. I just plugging 3 back in here, guys. That's all I did, plug 3 in there. I plug negative 1 inside there, so negative 1 squared right now is just going to be 1. 2 times negative 1 is negative 2, and then plus 3. So this becomes negative 1 plus 3, so this is 2. So my point is negative 1, 2. Okay, so those are my 2 points. Now, since there's no fractions or radicals or anything, I can just plug that into Desmos if I wanted to. I would get the same points there. Sweet. We're going to town on this, so let's move on. So this one, yeah, I'm going to do this one by hand as well. Let's change this to equals 4y plus 4. Now watch what I do here. I'm going to take this as a substitution. I'm actually going to plug it in here because this is what x squared equals. Okay, I don't need to get x by itself. I can say x squared, and so that's x squared. I can solve it. So this is 4y plus 4 equals, sorry, not equals, plus, sorry, plus, and then I have y minus 3 squared equals 16. Now everything is in terms of y, which is what I want, and so now I can start solving for this. So this is 4y plus 4. When I do this, this is y squared minus 6y plus 9. That's when it's FOILed out. So y minus 3 squared equals y squared minus 6y plus 9. Okay, just FOIL it out. That's all you're doing. Y minus 3 times y minus 3. Okay, FOIL it. And that's what you get. And then equals 16. Let's start combining a lot of stuff here. So this is y squared. The y's can combine, so negative 2y. 4's can combine, so that's going to be plus 13 equals 16. So y squared minus 2y minus the 16 over, so negative 3 equals 0. So that means this breaks down to y minus 3 and then y minus plus 1 equals 0 when I factor it. And so y equals 3 and then negative 1. Now, I still need to find my x's, so it doesn't matter where I plug it in. Let's plug it into my one right here. So let's do that. Sorry, but that's what I'm going to do. So in blue, I'm going to plug it in. So that means this is 3 squared minus, nope. I'm not plugging in my x's, plugging in my y's. Almost messed up there. So this is x squared. and then minus 4 times 3 equals 4. This is x squared minus 12 equals 4. This is x squared equals 16, which means x equals positive or negative 4, which means I have 2 points here, way at the bottom. I have 4, and then I have 3, but then I had negative 4, and then I have 3. Okay, so I have plus or minus x there, but I came from the same range. So I have these points so far. Okay, now I do negative 1. If I plug negative 1 in there, I'm going to just do x squared, and then this minus 4 times negative 1, and it equals 4. So x squared plus 4 equals 4. So x squared equals 0, which x equals 0. No plus or minus there. So what's my final answer? So 0 and then negative 1. So I have 3 points. Okay? Awesome. I'm just going to town on these. Okay? So let's erase that. I'm probably going to skip this for the sake of time. And then this, I actually did show you on the video for Desmos. So I'm actually going to skip this one as well. So this one, all you have to do, guys, is just plug this into straight up Desmos, like x squared plus y squared equals 1, and then you'll get your 2 points. It's very, very easy. So just plug it into Desmos, and then you'll get where they intersect. Okay? Again, for the sake of time, I want to get to the review, so I'm going to skip all that. Okay. So 3 questions, just like the 3x3 linear systems. 3 questions, 30 minutes. You have open notes. Send any partial credit requests to me via email if you need to. Just if necessary, do that. And then, yeah, get started on your Unit 1 review. You don't need to watch the rest of the video to do the Unit 1 review at all. So you will basically just have 20 questions. It will be 90 minutes tomorrow for the review. There will be Algebra 1 review on there, okay? So there will be some Algebra 1 review, some like graphing lines and stuff like that, some 2x2 systems, of course. There will be sequences, some functions, piecewise functions, and rational proportions, all that. So there'll be a lot of stuff on there, 3x3, nonlinear systems. So please, please, please review, okay? That's all I can say. Just review. You need to review, okay? It will help you, I promise you. If you only do a couple questions before you take the test, yes, you can retake the test, okay? But it'll be different. It'll be different questions, and so I encourage you just to do the review. All right. So I'm going to do these really, really fast. If you feel like you just know how to pretty much do everything, or you just want to work alone, then by all means, work alone, and you don't need to watch the rest of this. But I am going to go through these very, very fast. Okay. I have tons of slides I just want to go through, so I'm going to go through them. Here's a proportion where x cannot equal 0. So that's the first thing it's going to ask you. X cannot equal 0 because that's my exclusion. If 0 is down here, the world explodes. I can't have that. So now what is my actual least common denominator? I need to multiply everything by 8x. This will eradicate. When I distribute all the way through, it will eradicate my denominators, and that's what I want. So I'm actually going to do that all in one swoop. So I hope you guys don't mind. Okay, I'm going to do it all in one swoop. Okay. So are you ready? 8x times this first part. The x's go poofy, so I'll have 8 times 2, which is 16. 8x times 3 is going to be plus 24x. 4x or 8x divided by 4x. The x's go poofy, and I'm left with 2. 2 times 3 is 6. And then 8's go poofy right here. And now I'm left with the x's, so 25x, okay? I subtract the 24x over, and I subtract that over, so I have 10 equals x. And that's all I have. It's that simple, okay? So when I subtract the 6 over, I get 10. Subtract the 24x over, I get just 1x, so 10 equals x. Boom, done, solid. I'm good. Now, this next question is a values question, so I'm going to plug in 9. So that means f of 9 equals, so I have 9 squared. And and then, whoops, minus 2 times 9 minus 1. What this equals is 81 minus 18 minus 1. And then, of course, I can just use my calculator. I'm going to use my TI-36X Pro. You can use Desmos. The 81 minus 18 and then minus 1 gives you 62. Okay? So, sorry, there's like something on my seat. Okay. Awesome. So now, B, let's do B. Let's do B right here. So I'm going to plug in x plus 4 right here. So that means f of x plus 4 will look like this. So I have x plus 4 squared. And then I have minus 2 times x plus 4. And then at the end, minus 1. So what does this equal? X plus 4 squared is going to be x squared plus 8x plus 16 when I FOIL it all out. Remember, this is the same thing as saying x plus 4 times x plus 4. Okay? It's the exact same thing. I FOIL it. Okay? And then minus 2x minus 8 minus 1. This equals x squared. Those combine to be plus 6x. 16 minus 8 is 8. And then minus 1 is 9. So plus 9. And that is my final answer. I think that's right. No, not plus 9. 7. I was like, something's up. Something's wrong. So 16 and then minus 8 is 8. Minus 1 is going to be plus 7. Okay, so that's my final answer. And then C, I have negative x. So I'm just going to plug negative in. So if I plug in negative in like this, I get this. This becomes always a positive because it's squared. This becomes a positive and then minus 1. So that is my final answer. Okay. Again, this should be review by this time. Like it should be review. Okay. I'm just showing you kind of the general gist. Okay. I kind of know how to do all that and so forth. So let's erase. And let's go to this question. So this question has to do with functions. We first want to find the domain. So what is the domain? The domain right here is negative infinity to positive infinity. We read it left to right. Okay. This goes on forever. That goes on forever. The graph will always exist in all x values. My B is my range. So my range is, does it exist from bottom to top? It does exist down here. So it's negative infinity. But where does it stop existing? It stops existing at this, 0. Okay, it doesn't exist up here. It exists right here, but it doesn't get past 0 because it doesn't go past the x-axis. The x-axis is y equals 0. Okay, the x-axis is the same thing as y equals 0. They mean the exact same thing. So since it doesn't go past y equals 0, and it never touches y equals 0, is it included? No, so it's 0 parentheses, okay? 0 parentheses, it's never included. So this is my domain and range. My C, my x-intercepts. Well, if it never touches the x-axis, are there any x-intercepts? The answer is no, so it's none. Okay, what about D, my y-intercepts? There is one place where it crosses right here. That's negative 1, so negative 1. Awesome. Now E. E is my missing function, f of 1. So f of 1. Let's erase all this so you can kind of see it clearly. F of 1. What is f of 1? F of 1, remember, is my x-axis, or not my x-axis. It's my x value. This means x. So 1 right here. Okay, that's what I want. Where does it cross? Where does it hit? What's that y value? Negative 2. So this equals negative 2 because this is a point. Not 1, not negative 1. This is a point. Wow, I did it again. How about this? 1, comma, negative 2. Okay, so that is a point right there. But this is my actual answer that Math Excel will want. Okay? Sweet. All right, let's move on to some other reviews. So this is the rate of change formula. Let's do purple. So my rate of change formula right here is f of x2 and then minus f of x1 all over x2 minus x1. Okay, so I have something like this. So I plug in my x2 into my x's. Okay, so in brackets, x, it'll look like this, 6 squared plus 8 times 6. And then minus, following my formula, I plug in my x1 into here. So that is 3 squared, and then plus 8 times 3. And then all over 6 minus 3. Okay, 6 squared, so let's start simplifying, is 36 minus, plus 48. That's 9 squared, bracket, not 9 squared, 3 squared, which is 9, 3 squared, which is 9, and then plus 24. And this will be all over 3. 36 plus 48, I believe that is 96. So 48 plus 36, 84. I was off by 12. Dang it. 48 plus 48 is 96. So 84. So that's 84. And then minus, this is 31. 33. Wow, not really good with my adding today. And then all over 3. 84 minus 33 is 51. Divided by 3 is 17. So 51 divided by 3, and that equals 17. So that is my final answer. That is my slope, technically. My slope, my secant line, if you remember, the slope of my secant line at that question. All right, this is arithmetic. So arithmetic, we want to use a formula, find the general term formula, and then find a sub 20. So the first thing is first, this is my formula. Now, this is not what you're going to be plugging into Math Excel. This is your formula that you're going to be utilizing to find your formula that you want to plug into Math Excel. What's my a sub 1 value? That's 1. What's my d value? My d value is plus 7. So plus 7, plus 7, plus 7. So that means it's 7. So now let's plug it in. I don't care about n right now. My a sub 1 is 1 plus my n minus 1 and then times 7. I can distribute. So this is 1 plus 7n and then minus 7. So this equals 7n and then minus 6. So this right here is my a sub n value. This is the first thing that they want to ask you. That's your general term. The second thing they're going to ask you is what's a sub 20. A couple ways you could do this. You could plug it in right up to the original, or you could just plug it in right here, and that's what I'm going to do. So this is 7 times 20, and then minus 6. 7 times 20 is 140, minus 6, so that equals 134. So 134 is your actual a sub 20 value. Okay? Sweet. We're just going to town, just reviewing some of these questions. I hope I'm not really trying to teach you this, guys. Like, I'm not trying to teach you these. I'm just trying to review it for you. Okay, that's why I'm going fast, because this stuff you should already know or beginning to already know. So if you really need it to be taught to you, go back to that lesson where I teach it to you. Go back to the video. This is not the time where I reteach it. Okay, so let's go over here. What do I do on this case? Well, this is a piecewise function. I look at -1. Remember, I need to find my domain restrictions right here. These are the domain restrictions. DR, domain restrictions, which means with this piecewise function, I need to kind of plug -1 into whichever one follows my domain restriction. -1 is less than 0, so if this is x, is it greater than 0 right here? No, so it's not greater than 0. Can't use that, but it is less than 0. -1 is less than 0. My x is less than 0, so I need to plug it in for that one. So what is that going to look like? P -1 equals -1 and then 5. And then this is going to be plus -1 to the 4th, and then plus 40 times -1 and then minus 40. So -1 to the 5th power is a -1 times another negative is a positive 1. -1 to the 4th power, since it's even, is a positive 1. This is going to be minus 40 and then minus 40. So this equals 2 and then minus 40 minus 40. This equals -38 and then minus 40. So this equals -78. just following order of operations. Okay, that's all I'm doing. Doing the first two, 2. Next 2 is going to be negative 40, or 2 minus 40, which is negative 38, and then minus the last 40 here. Order of operations, baby. That's it. Solve this by the addition method. Awesome. So I'm going to probably, first of all, get rid of this. You could definitely do this on Desmos, but I'm not going to. So I'm going to actually multiply and get rid of my x's here. So I'm going to multiply this by negative 3, multiply this by 4. So my next one, my new one is negative 12x, and then plus 6y equals 60, because the negative 3 goes to everything. My new one right here is 12x, and then minus 20y equals 24. I add, goes poofy. I'm left with negative 14y equals 84. And I believe 84 divided by 14 is 6. Yep. So I divide that, so y equals negative 6. Plug it in. Let's just plug it in the bottom one. So 3x minus 5, negative 6 equals 6. So 3x plus 30 equals 6. So 3x minus the 30 over, so that's going to be negative 24, and so x equals negative 8. So that means my actual answer is negative 8, negative 6. And yes, I could have plugged that into Desmos if I wanted to, but I am not going to. Okay, sweet. Let's erase, and I think this is one more. This is the last. I'm not going to go, for the sake of time, I'm not going to do this one. I know, sad day. Go back to the video, go through your Math Excel 3x3 homework assignment. I was going to explain it fast anyway. So this one, how do I do it? Well, first of all, I need to select this one. So I need to get to another equation. I'm going to use 1 and 3 and eliminate my x's. I want to eliminate my x's so I can get them together. So if I eliminate my x's, then I can get y and z together and so forth. So let's do 1 and 3, which means I need to multiply this by negative 3, positive 3. So my first one doesn't change. I'm just going to write that down. My third does change, so this becomes 3x. This 3 negative 6y and then plus 3z equals negative 12. Add them up. That goes poofy. And this becomes negative 7y plus 3z equals negative 6. Okay? And then I take this and actually I perform the system with it. So this is y minus 4z and it equals 8. Okay? Now what I need to do is probably multiply this one by 7. This one seems familiar. Did we already do this? I feel like we already did this one. If so, that's unfortunate, but I'm going to continue doing it. Okay, so my new equation, this one doesn't change at all. This one stays the same. Oh, man, why did I do a y there? Okay, so this one stays the same. This one is negative, it's not negative. I'm going to make it positive. Sorry, 7y. And then minus 28z equals 56. We definitely did this one. Okay, that goes poofy. This becomes negative 25z equals 50. So z equals 2, negative 2. Z equals negative 2. Wow. Okay, negative 2. How do I do that? Well, I plug it back in here. So this is y minus 4, negative 2 equals 8. So that's y plus 8 equals 8. So y equals 0. And then I can plug it in right here. So negative 3x minus 0 equals 6. Negative 3 equals 6. So x equals negative 2. We definitely did this one. That sucks. Okay. Well, whatever. Wow, that's unfortunate that it actually happened to be like that. That's crazy. So that is negative 2 and then 0 and then negative 2 as well for my z. Sorry about that. That's actually the same. Kind of unfortunate. I'm still not going to do this one because I don't want to take up any more of your time. So I'm going to erase. And again, if you have any questions, please let me know. If you do the Unit 1 review at 100%, okay, you will get up to 5 extra credit points on the unit test. Okay, 5 extra credit points on the unit test. Yes, that is about 5%. So, awesome. All right, guys. So this is the last video. There won't be another video for the test. This is the last video for Algebra 2.1. I hope you guys really do good on the test. If you don't, that's okay. You can retake it. But this is C-squared mathematics. I'm Mr. Carlson. I hope you learned a lot during this unit. We're going to come back with a bang with the next unit on complex numbers and what complex numbers do for us in mathematics. See you guys later.